Hey guys, it's me again. Math 2203, Calculus 3. This time it's 10.2, Introduction to Vectors. So the difference between a vector and a scalar value, for those of you that don't know the vocabulary, is a scalar value has a magnitude, but it does not have a direction. So this means like your speed of an object, mass, time, things like that. A value or a vector value has both a magnitude and a direction. So this could be your velocity, your acceleration, your force, those things. Whoopsies, I forgot to put pictures. Well, that's on me, but since this is an easy subject, I'm not going to fret too much over it. So vectors have an initial starting point. This is where you're going to start drawing your line, and a terminal ending point, which is where the arrow is going to be, the arrowhead. So I can help you picture it without any pictures. The magnitude of a vector is the distance between those 2 points, and vectors are typically written in bold or typed in bold. And if you handwrite them, then they have this little arrow above them. I'm pretty sure if you're trying to learn Calc 3, you should know about the vector notation. In this PowerPoint, I'm going to write them in red because the bold doesn't show up very well. I, again, didn't add pictures, but it's okay. In order to add 2 vectors, we align the terminal point of the first vector up with the initial point of the second vector, and calculate the resultant vector by going from the head, or like the terminal point of the first vector, the initial point of the first vector with the terminal point of the second vector. So basically you're trying to draw a triangle with them. So here's some properties of vector addition. It includes it being commutative. I always say commutative, but it's commutative. Anyway, that just means they can be added together in any order. Vector addition is associative, which means if you have a bunch of vectors to add, you can put your parentheses and group them up however you want to, and they still, have the same sum. The additive identity property is when the additive identity, a zero vector, and any other vector is added together to receive a sum of the second vector you added. So basically, vector 1 plus vector 0 equals vector 1. There you go. And the additive inverse property is essentially subtracting a vector from itself to receive a zero vector. Just don't say that it's subtracting, because technically we don't have subtracting. This is what we have. We have that v minus w is actually v plus negative w, which means that we're changing the direction of the second vector, whichever vector we're wanting to subtract, in quotation marks. So you're basically just saying, hey, instead of going this way, go that way, and then I'm going to add you two together. And then there's scalar multiples. If a letter A is a scalar quantity and is multiplied by a vector, then the resultant vector is considered the scalar multiple of the original vector. And that resultant vector will have a magnitude 8 times greater than that of its original vector. So vector 3 times a scalar 3 is going to become vector 9. And some properties of scalar multiplication: 0 times a scalar, or not a scalar, a vector, is a 0 vector. A plus b, which are both scalar values, times the vector equals a times the vector plus b times the vector. one vector equals itself. A times vector v plus vector w equals A times vector v plus A times vector w, which is distributive property, just to throw that out there. And then negative 1 vector is the negative vector, which is just the opposite direction. And A open parentheses b times the vector close parentheses is the same as AB times the vector. And if you would like to go over graphing vectors or anything like that, you can either let me know if you want me to do it, or you can just go watch some other videos. It's not that difficult, so I can leave that up to you guys to study. And if you're wanting to see like the pictures that I needed here, you can really just look up like vector initial point, vector terminal point, vector addition, things like that. I guess I got a little lazy on this one. I'm sorry about that. But the other ones are better, I promise. So that's really all there is to this. Also, I want to point out on this slide, notice that there's not like 0.v or 0xv, because dotting a vector and crossing a vector are different, and we'll get to that later. So, hope everyone enjoys this video if you actually watched it and needed it. Hoped it helped at least a little bit. And I'll be getting back with some more videos.